Dear participants, my name is Ivan Pavlenko. I'm representative of Sumy State University. I'm a professor at Sumy State University Department of Computational Mechanics, named after Volodymyr Marcinkovsky, and Vice Dean for Research of the Faculty of Technical Systems and Energy Efficient Technology. Also, I represent the Journal of Engineering Sciences as the managing editor, and on behalf of our editorial board, I kindly ask you to submit your research articles to our journal. It's a great honor for me to be a chair of this session number 8. The today's sessions named as Chemical Engineering, the second part. Remarkably, the session is based on recent developments in chemical engineering, energy efficient technologies, and industrial ecology. It consists of 5 researchers carried out by 25 representatives from 7 institutions from 4 countries, such as Japan, Poland, Kuwait, and Ukraine. Please pay attention that you have 8 minutes for your presentation. The discussion, answers, and questions will take 2 minutes. I cordially ask you, all the participants, to make their answers to be involved in each discussion. Okay, let's begin our session, and I sincerely wish all the speakers to make the presentation successfully and share their contributions and latest achievements with your international scientific community. The first presentation is Equipment for Oilfield Wastewater Treatment Using Swirling Flows by authors Alexander Lepощенko, Viktor Moiseyev, Alexander Starinsky, Evgenia Manoylo, and Hussein Seif from Sumy State University, Ukraine, National Technical University, Kharkiv Polytechnic Institute, Ukraine, and Al-Kharayev Company for Sale, Maintenance, and Repair of Oil Production Equipment, LLC, Kuwait. The speaker is Hussein Seif from Al-Kharayev Company for Sale, Maintenance, and Repair of Oil Production Equipment, LLC, Kuwait. You are welcome, please.
Thank you. Good afternoon, sir and madam. I would like, first of all, to thank the organizer of this meeting for inviting me here today. Welcome to my presentation. What I would like to present to you today is equipment for oil field wastewater treatment using swirling flow. Next flow, please. Next slide, please. I'm not seeing the slide in the windows. The oil and gas industry is one of the most environmental dangerous subsurface use industry and causes huge damage to the environment. It's characterized high energy intensity, significant pollution of vast territories. Petroleum products and reservoir water are the main environmental pollutants in this area. Reservoir water released to the surface changes to the micro relief of the territory, and it's a source of secondary salinization of soil around oil wells. Reservoir water contains petroleum, hydrocarbon, various salts, and mechanical impurities, which being absorbed by the soil and entering the groundwater dramatically change their chemical and physical properties. Recently, when developing oil well, the technology of injecting produced water into the well to maintain pressure is used. More than 90% of oil field wastewater is used for flooding oil reservoirs. Flooding of oil reservoirs allow increasing oil recovery by 1.5 to 2 times. Next slide. The current scheme of pumping wastewater back into the reservoir at oil field with the addition of reagent to increase oil recovery leads to a significant change in the chemical composition of reservoir waters, which affects the state of the subsurface and also creates a threat of spreading pollution to other aquifers. In solving this problem, one of the main tasks is to purify oil-containing reservoir wastewater in order to achieve stable characteristics of the natural environment with acceptable parameters of contamination, as well as possible extraction of valuable component from recycled water. Next slide. Oil field wastewater purification is carried out by mechanical and hydromechanical process, mixing, settling, centrifugation, and filtration in order to destroy the armor shells on oil droplets, coalescence of oil droplets, and remove of partially concentrated oil phase and sediment. For the treatment of reservoir wastewater in the oil industry, the method of settling and settling tank is used. But this method often does not provide the necessary degree of cleaning. Therefore, tanks with agitators, settling tanks, separators, centrifuge, hydrocyclone, drop forming units, flotators, and filters are also used as equipment. In order to successfully purify oil field wastewater, for quickly reduce the aggregative and kinetic stability of oil droplets oil field wastewater purification units and devices are developed that increase the effect, depth, and speed of the purification process. Due to this, oil droplets are rapidly enlarged to coalescence process. A polydisappears system turns into a monodisappears one. A high and stable effect of cleaning oil field wastewater can be achieved by pre-hydrodynamic treatment of it in a swirling steam. Next step. Next slide. In hydrocyclone and sedimentation chambers, the armor shells are destroyed. The oil droplets are fragmentary and coalesced. The monodispersity increases. Due to hydrodynamic treatment of the swirling flow, a high and stable effect of swirling cleaning is achieved in all areas of the swirled flow. The swirling flow is expanded, the swirled flow is properly damped. The flow energy is used for the most effective implementation of the mechanism of destruction of oil emulsion. The separation of oil droplets from water in an emulsified state is performed in cylindrical counter-current hydrocyclones of small diameter. The treated water entering the hydrocyclone through the tangential inlet receives a rotational movement under the influence of the resulting centrifugal force, which exceeded the force of gravity by hundreds or thousands of times. The particles of impurities are thrown into the external drawn flow, which moves in a spiral to the lower discharge port. Next slide. The use of hydrocyclones as a stage of wastewater treatment can significantly increase the compactness of the entire treatment scheme and facilitate its operation. For water purification from oil and suspended substance, depending on the required degree of purification, the following devices are used. One, at the first stage of cleaning, hydrocyclones and settling tanks. Second, in the second stage, hydrophilic and hydrophobic filters. Three, for better water purification, coalescing filters. The separation mechanism of three-phase system in hydrocyclones is as follows. Solid particles under the action of centrifugal force move to the wall of the hydrocyclone and along a helical trajectory move down to the lower outlet, through which they are removed from the hydrocyclone. The efficiency of the water purification from oil depends on the design of the hydrocyclone and varies from 84 to 89%. Recommended parameters of the hydrocyclone: diameter of cylindrical part 75 mm, diameter of inlet port 15 mm, diameter of the axial port 10 mm, diameter of the discharge port 20 mm, taper angle 10 degrees Celsius, inlet liquid pressure 0.17 megapascal. Next slide. The research methodology. In this article shows some technology parameters and values for calculation of cyclone installation. As we can see, so the multi-hydrocyclone can be used as the main element in the wastewater treatment system, provided the regime is observed in which there is no overexpression of the remaining oil in the water in oil. The acceleration of movement does not exceed the value of 1,000 grams. The device implements a mechanism for separating light oil and gas and heavier fraction water and oil. Next slide. In this slide, multi-hydrocyclones make it possible to achieve a deep degree of purification, and their use is promising both in the system oil-filled wastewater treatment and in system of primarily water discharge. It's advisable to treat oil-containing wastewater for reuse in accordance with this scheme. The oil-containing wastewater flows into a receiving tank, sometimes into a pre-sump. Then the wastewater is sent for treatment by pumps, in particular the pressure hydrocyclone, in which large mechanical impurities are separated and dumped into a hopper. After passing through cylindrical conical hydrocyclones, thin layer settling tanks, wastewater enters in cylindrical hydrocyclones for purification from petroleum products. After hydrocyclones, the purified water is sent to flotator, coalescing or sorption filters. If necessary, the final purification of water in the sorption filter to the content of petroleum products of 0.05 milligram per liter is possible. Next slide. The treated water is returned to the well, maintain reservoir pressure, the cleaner the water being pumped into the formation. The greater the intake capacity of the injection well, and the lower the required amount of water and the lower the cost associated with pressure maintenance system. General requirement for pumped water is limited content of mechanical impurities and iron components, absence of hydrogen sulfide and carbon dioxide to prevent equipment corrosion, no organic impurities like bacteria, algae, chemical compatibility with reservoir water. The degree of oil wastewater purification is determined individually for each oil well. The permissible content of mechanical impurity is 3 milligram per cubic decimeter, and petroleum products 5 milligram per cubic decimeter. The presence of mechanical impurities is one of the main factors that cause a decrease in the permeability of the bottom hole formation zone when using both fresh and reservoir waters. Next slide. The results of hydrocyclone simulation method are present in this figure. CFD simulation of separation process in SPR separator. In the left, counters of the water volume fraction in the middle section of the SPR separator, and in the right, can see the vectors of water velocity. The result of the numerical simulation point out that the action of centrifugal forces are provide separation efficiency. The separation efficiency was calculated using the dependence and its compounds. The usage of these separators type at the separation oil product stage may significantly increase the degree of wastewater treatment and the intensity of the present units. Slide 11. The conclusion. Modern industrial methods of oil field development require the use of new equipment with a high cleaning effect and a single capacity, tightness, and easy of factory, the manufacturer, and installation. The amount of capital investment for the construction of treatment facilities is reduced several times, and operation costs are reduced by 15%, improving the sanitary and environment condition of operation of the plant. No less important advantage of the scheme with hydrocyclone is significant space savings. Thus, in order to protect the environment, the following measures are necessary. First, ensuring deep treatment of oil field wastewater. Extensive use of anti-corrosion coating and chemical reagents for corrosion protection of oil-producing equipment. Full use of wastewater obtained in the field in the reservoir pressure maintenance system. Monitoring of the state of surface water and the quality of wastewater used in the reservoir pressure system. The developed methodology was released within the research project and implementation of energy efficiency modular separation device for oil and gas purification equipment. Thanks for your attention. Thanks.
Dear Dr. Hussein Saif, thank you for your presentation. And now we have one question from our chat. So please answer the following question. Slide 7 presents velocities for laminar and turbulent modes. In this regard, maybe it would be better to propose the unified dependence of particle precipitation velocity on the Reynolds number. And have you considered resistance forces of different nature, like such as drag forces, historical Basset forces, or many other forces, or maybe it will be your research in the future?
It will be in the future, our research for the other forces. Now we are focusing on Archimedes force and centrifugal force in this case.
Okay, thank you. Thank you for your presentation. Thank you for your answer for these questions. And I highly appreciate your participation in the conference. And thank you. See you.
Thank you. Thank you. See you soon.
Colleagues, the second presentation is thermal characteristics of the wet pollution layer on condensing heating surfaces of a host gas boilers by authors Victoria Kornienko, Roman Radchenko, Tadeusz Bogdal, Mykola Radchenko, and Andriy Andreev from Admiral Makarov National University of Shipbuilding, Ukraine, and Koszalin Technical University, Poland. The speaker is Victoria Kornienko from the Admiral Makarov National University of Shipbuilding, Ukraine. You're welcome, please.
Hello, everyone. The topic of my research, thermal characteristics of the weak pollution layer on condensing heating surfaces of exhaust gas boilers. Next slide, please. The application of condensing low-temperature heating surfaces in exhaust gas boilers allows to increase the environmental performance of the low thermal power plants and their economic efficiency due to deeper exhaust gas heat utilization. The fuel oil combustion leads to increase of the low temperature corrosion intensity up to 1.0 millimeter per year at low temperature above the dew point temperature of sulfuric acid vapor, 130 degrees. Water fuel emulsion combustion with water content 30% make it possible to the degrees of low temperature corrosion intensity to the level 0.25 millimeter per year. In this case, it becomes to apply condensing heating surfaces in exhaust gas boiler with high working reliability on these surfaces. The recommendation for the design of dry convective surfaces were developed. But there is no literal data on the values of pollution coefficients of condensing heating surfaces when water fuel emulsion are used. Next slide, please. The aim of research is to obtain dependencies of heat transfer and thermal efficiency coefficients from the low temperature for condensing low temperature heating surfaces. The research task. First, to carry out the experimental researches of low temperature heating surfaces pollution process of exhaust gas boiler that influence heat transfer intensity and exhaust gas boiler working reliability. To develop a method for determining the pollution coefficients for condensing heating surfaces, and third, to determine dependencies of the pollution coefficients for condensing heating surfaces required for the design calculation of convecting heating surfaces of exhaust gas boilers. Next slide, please. Experimental researches of pollution process intensity at low temperature below the dew point temperature of sulfuric acid vapor were carried out in experimental setup with combustion of fuel oil and water fuel emulsion based on them. The experimental installation includes the following elements: combustion chamber, fuel preparation system, burner, and gas duct. A rotary nozzle is used as a burner. There were working areas with tube samples provided in gas duct to study pollution process. Cooling of samples were carried out with water from thermostats. Next slide, please. Therefore, in order to estimate the pollution intensity when combustion of various fuels with different combustion regimes, pollution process kinetics of short-term experiments was studied in order to obtain approximate equations that will enable to predict development process at any time. Next slide. The adequacy of obtained results were evaluated by comparing received values of pollution intensities with published operation data and the results of long-term experiments for 100 and 1,000 hours. Next slide, please. The pollution layer on condensing heating surfaces is a porous layer of deposits with bulk density of solid particles. The thickness of the pollution layer presented on figure 5. Next slide. The thickness of pollution layer and its thermal conductivity depends on the porosity value. According to the adopted methodology, it's assumed that the layer porosity is 0.3 when fuel oil is used, and the average porosity value is 0.48 when water fuel emulsion is used. Next slide, please. It was decided to use the Maxwell formula number 1 to determine the value of thermal conductivity, which take into account the porosity of the liquid filled deposits. When determining thermal conductivity for zone of layer with a vapor acid mixture, it's necessary to take into account the degree of dryness of this mixture in the layer, as well as the dependence of sulfuric acid concentration on the low temperature. At low temperature, 140 degrees, the degree of dryness was taken to be 1. At temperature 110 degrees was equal 0, and at temperature 130 degrees was 0.9. The value of thermal conductivity for this temperature range was determined by formula number 2. The thermal conductivity of solid particles depends on thermal conductivity of soot and ash particles and their concentration. Formula number 3. Next slide, please. The dependencies in figure 8 show an increase of pollution coefficient with increasing low temperature. For condensing heating surfaces, the pollution coefficients during combustion of water fuel emulsion are lower in 2 times in comparison with combustion of fuel oil. The dependencies of the pollution coefficient make it possible to determine the values of the heat transfer and thermal efficiency coefficient. Next slide, please. Therefore, the thermal efficiency coefficient during the combustion of water fuel emulsion is higher, which at the same thermal power will reduce heating surface. A significant decrease in the thermal efficiency coefficient in the condensation zone at the time of expose the gas flow 1000 hours indicates that in order to obtain high values of thermal efficiency, it's necessary to reduce the period between the cleaning to 8 hours. And conclusions. For condensing heating surfaces, the pollution coefficient during combustion of water fuel emulsion are lower in 2.2 times. Heat transfer and thermal efficiency coefficients are in 3.5 times higher in comparison with combustion of fuel oil. The obtained dependencies of the pollution coefficients for condensing heating surfaces are recommended for use in standard methods for the design calculation of convective heating surfaces of exhaust gas boiler. Thank you for your attention.
Victoria, thank you for interesting presentation. And now we have one question. Particularly as follows: the experimentally obtained dependencies of the pollution's specific mass and process intensity on time, presented in figures 2 and 3, contains coefficient of and power numbers. Could you clarify why this power function and dependencies have been proposed, and what factors impact on values of these coefficients? Why these analytical dependencies has been considered in your work? Maybe they are based on the physical processes you are considering. I think you have based on the best, the minimum relative error of this dependence, maybe, yes?
Yes.
The least square method, maybe. Yes, I think. So, okay. Thank you for your presentation.
Thank you.
I wish you good luck and see you next time. Thank you.
Thank you.
Okay, dear colleagues, let me introduce the third presentation, named Stimulation of Anaerobic Fermentation of Wastewater and Sewage Sludge, by authors Елизавета Черниш, Igor Roy, Victoria Chubur, Manabu Fukui, and Ivan Kazi from Sumy State University, Ukraine, Institute of Low Temperature Science, Hokkaido University, Japan, and International Innovation and Applied Center, Aquatic Artery, Ukraine. The speaker is Dr. Елизавета Черниш from Sumy State University. You're welcome.
Thank you for introduction. It should be noted today I have speak together with my PhD student, Victoria Chubar. We have together that presentation. And about some organization issue. I tell the next slide and you show, because I don't see a slide under your programs. Okay. In my pleasure to present your attention the topic stimulation of anaerobic fermentation of voiced waters and salt slide, and of course the next slide, please. You see that now it's really challenges in nowadays in world, because the basics treatment and wastewater systems and slide recycling is necessary to provide new innovation approach, complexes approach that can be very useful and life safety protection in general. And under this possibility, tell about using waste water and sewage sludge for biobasic products production, and get energy and fertilizer. Please, next slide. I'm and research task. It should be noted the study aims to determination regulation modern terms in the field of stimulation wastewater treatment and salt sludge transformation component under anaerobic conditions, and get sustainability system for provide mechanism of magnetic fields influence on biobasic processes. It's really have such targets, you know, and of course magnetic fields can be different type of impact on bioprocessing. Under these arms, we have such research task. It's a visualization of the network system and simulation of aerobic fermentation processes of wastewater and sewage sludge, and analysis of the effect of magnetic fields on bioprocessing, and forming general model, a theoretical model that can be a practical impact also. Please, next slide, research methodology. If you see, we use a database that forming collection of data from different research in the world. This database, for example, Scopus, but it can be Web of Science and others database. It's depend of access for such data. Analysis of such publication activity as our research fields using online tools that help to provide analysis statistics and other keywords specified for these areas. And the next stated use software, especially software for visualization and forming network maps that can provide more tendencies under this field with use clusters that have such features connection for different type of technological approach under our topic. Please, next slides. We see that software that we use is was your. It's free access, I should be noted, and it allows the present results of analysis, different combination of citation, co-authorships, interrelation of keywords, and forming very interesting clusterization that we show in our results. And next slide, please show methods of visualization, and we use under this process, because we estimation anaerobic condition under bioprocessing, we use different biochemical bioinformatical database such as Kyoto Encyclopedia of General Genomics. It's a very popular bioinformatic database that provides useful information about bioprocessing and how involving different groups of microorganisms to our anaerobic fermentation in different states. So its connection is very well interesting, and we form a sort of mix of approaching to estimation how it can be impacted magnetic fields on wastewater treatment system and such sludge recycling. And next slide about results. I think Victoria can continue.
So now let's move on to the results. Through the WASViewer program, a visualization of cluster interconnection by keywords stimulation and anaerobic fermentation was carried out in a research publication of various savage slug and wastewater treatment fields. The cluster were formed through the network. The red cluster conducted with an area of enzyme activity of use of biostimulants for microorganism grow under anaerobic digestion and ecosystem bioremediation. The green cluster associated with general fermentation processes and the junction of anaerobic and aerobic condition using different type of co-substrates. The blue cluster has generalized the use of microorganism genetic modification methods used in anaerobic fermentation processes. While analyzing the visualization cluster in the stimulation of anaerobic digestion processes, we also noted studies on biostimulation of bacterial activity processes using magnetic and electromagnetic fields. There is a large amount of contradictory data. Next slide, please. The generalized study results of static and alternative magnetic field effects indicate that the effect of are controversial, mainly reduced to positive and negative effects. Also, the data from some studies testified that there is a stimulating effect on magnetic fields as an increase in biomass and metabolic activity, but most experimental confirms that the negative effect of microorganisms also there, as a reduction in the consumption of substrate, inhibition of bacteria growth, for example. The contradiction of the influence on bioprocesses is due to the lack of unified approach to the regime and design parameters of processing microorganisms with magnetic field. Thus, exposure to electromagnetic and magnetic fields is promising for application, but requires further discussion of the effect on anaerobic digestion. Next slide, please. The biological effect of an external magnetic field must be associated with the effect of external field on the water in a metastable state that are different from an equilibrium. This metastable state is transmitted further to the biological level through water participation in various metabolic processes reaction. The metastable state and nature of the biological activity of water are associated with the formation of supermolecular structure in water, the presence of ortho H2O and para H2O states of water molecules, and their ratio. Ortho H2O are more mobile and interact weaker with the surface of particles, in contrast to the para H2O state of water. Next slide, please. After short-term exposure of the magnetic field on the aqueous solution, the mechanism of effect occurrence during treatment with the external magnetic field on biosuspension can be applied to describe the processes. Thus, special attention should be paid to the mechanism on manifestation unification of the positive effect of magnetic field on biosuspension. Next slide, please. According to this concept, a generalized model of magnetic field stimulation effect on bioprocesses was formed and presented on the slide. An increase in an amount of ortho H2O in the water layers surrounding the bacteria will improve metabolism by accelerating the exchange and rearrangement of water molecules in hydride shells of ions and molecules that are involved in cell metabolism. The model can be used in anaerobic digestion of savage slug and wastewater biotreatment to produce useful bio-based products. Next slide, please. In conclusion, let's sum up the main points. The development of effective stimulating method on municipal savage slug anaerobic fermentation is important in the context of the integrated approach to savage slug and wastewater disposal. Through the WAS viewer program, the network system was visualized with emphasizing the biostimulation of microorganisms through the influence electromagnetic and magnetic fields. The effect of magnetic fields on the vital function of microorganisms is controversial. However, exposed to the magnetic field on the aqueous solution improves bacteria metabolism. And it appears that the behavior of bacteria is similar to the formation of biofilms. Therefore, it presents a perspective for the management of chemical, biochemical, and biological processes. Finally, to highlight, it is necessary to carry out further experiment studies to confirm mechanism of magnetic field influence with the complex of other stimulating factors on the savage slug anaerobic fermentation processes, to intensify the process of heavy metals removal and formation of such bio-based products as ecologically safe, digestate, and biofuel. So next slide, and Elizabeth, you're gonna continue.
Thank you. About acknowledgement, it should be noted, it's really very thankful for our Japan colleagues, and when I was in Japan, it's really a very interesting experience to be in the Hokkaido University and work together with Dr. Manabu Fukuye. So we are thankful for the Japan Society for the promotion science support which allows science cooperation to start under this topic, and it's really interesting now about basic process and browsing level of impact and in different technological processes and have different implementation, and together with our Japanese colleagues and colleagues from different countries in Europe, we continue our work at the International Applied Innovation Center Aquatic Arteria, and hope to find a new opportunity to work under this topic and other topic for reduction technogenic impact on water resources and provide new useful, ecologically, environmentally friendly technologies for wastewater and third sludge treatment. Thank you for your attention.
Thank you. Thank you. Anybody has a question? Does anybody have a question, please? There are no questions. So thank you for amazing presentation and sharing your experience based on your previous research in Hokkaido University, Japan. It's really interesting. I wish you good luck.
Thank you very much, and I hope in the next year we can gather together in really today, offline, not online, and our Japan colleagues can be together with us.
Okay, thank you.
Thank you.
I'd like to represent the next presentation. Efficiency of thermocompressor application in an ejector refrigeration machine, presented by authors Dmitro Konovalov, Galina Kabalava, Andrei Radchenko, Alexei Zelikov, and Viktor Khaldobin from Admiral Makarov National University of Shipbuilding, Ukraine. The speaker is Dmitro Konovalov. Please.
Do you hear me?
Yes.
Yeah. Okay. Hello, everybody. I would like to present presentation efficiency of thermopressor application in an ejector refrigeration machine. So the next slide, please. So with the active development of energy-saving and energy-efficient technologies for ship and stationary energetics, one of the promising areas to improve the efficiency is using of heat refrigeration machine for air conditioning and refrigeration system as part of combined energy production plants. Generation. Nowadays, the following heat-using refrigeration machines are used: an absorption refrigeration machine, an ejector refrigeration machine. The ejector refrigeration machines use is promising way which is inferior of energy efficiency to absorption refrigeration machines, but surpasses them in simplicity and overall dimensions. The next slide, please. To search for reservoirs for increasing the utilization and heat efficiency of power plants using heat-consuming circuits based on both heat using refrigeration machines and method of cooling, cyclic charge air or inlet air, or one can turn to the effect thermodynamic compression. It should be noted that the effect of thermodynamic compression in the heat-using ejector refrigeration machine depends largely on the thermodynamic and thermophysical properties of the refrigerant. Therefore, it's advisable to determine such a refrigerant which would provide the greatest pressure increase with the same vapor cooling efficiency, for example, before the condenser or after evaporator. Next slide, please. The thermopressor is a two-phase jet apparatus in which the gas pressure and gas cooling are increased by removing heat from the gas flow. With proper organization of the process of evaporative contact cooling, the effect of thermodynamic compression is taking place, a phenomenon in which gas pressure is increased in the process of instantaneous evaporation of liquid injected into the gas flow, accelerated to a speed close to sound. The next slide, please. The thermopressor has some advantages which makes them quite competitive compared with traditional heat exchangers and other devices. The absence of moving parts, complete tightness and high reliability, simplicity of manufacture and maintenance, and an ability to work without energy from the outside. The next slide, please. A comparative calculation method was used to determine the thermodynamic and energy efficiency of a thermopressor as part of a refrigeration machine. The calculation took into account the pressure loss in the nozzle, the working chamber, the diffuser, and the frontal resistance of the injected liquid droplets. A mathematical model was used in the developed calculation method based on the equation of the movement velocity, pressure, density, and temperature of the flow under the combined effect of two factors, consumption and heat. The next slide, please. One of the variants to reduce the vapor pressure at the exit of the ejector diffuser at a constant condensation temperature is to use a thermopressor in front of the condenser. Reducing vapor overheating in the thermopressor also reduces the thermal load on the condenser. Increasing the total pressure in front of the condenser will reduce the degree of pressure increase in the ejector and, as a result, increase the ejection coefficient and the thermal coefficient or heat coefficient. The flow of liquid refrigerant is carried out after it takes off from the circulation pump. This solution allows to provide a higher pressure for the injection by the nozzle of the thermopressor and accordingly to reduce the average diameter of the liquid droplets at the inlet to the working chamber. This makes it possible to increase the total increase in pressure in the thermopressor by reducing the relative length of evaporation and reduce the effects of drag on the gas vapor flow. The next slide, please. Analysis of thermopressor efficiency shows that a positive increase in the gas flow pressure will be observed only for some refrigerants, R142B and R245FA, and all other refrigerants are characterized by a decrease in total pressure due to the prevailing influence of resistant and low temperature differences in the thermopressor. In small amount of liquid should be noted, which should be injected for complete evaporation in the thermopressor. So for refrigerant R600 and R245FA, by 10 to 16%, the required amount of liquid for R142B is less and average by 5 to 10%. The next slide, please. Increasing the pressure in the thermopressor allows reducing the compression ratio in the ejector and accordingly increase the ejection coefficient. This in turn will allow providing the thermal coefficient. It can be seen that the greatest efficiency by using the thermopressor at the maximum possible boiling point the generator is emerged for the next refrigerants R2033 and R245FA. The next slide, please. From the above analysis of the ejector refrigeration machine effectiveness, we can conclude that it's necessary to use the thermopressor in other possible schemes. In such scenarios, refrigerants vapor cooling should be greater than 30-40 degrees, for example, in a cascade scheme or a two-stage scheme. The ejector refrigeration machine can be used as an upper and cascade. The thermopressor applying is also possible in schemes with intensified heat transfer in the evaporator, for example, when using the circulation of a liquid refrigerant using a giant pump injector. The increase in the coefficient of performance by 1.5 to 2% is expected due to increased pressure in the thermopressor by 1 to 2%. The next slide, please. Another promising solution is to use the thermopressor in a circuit with heat recovery in a regenerative heat exchanger. In this case, it's advisable to install the thermopressor behind the evaporator at the ejector inlet. Such solution reduces superheating of vapor at the suction of the ejector and provides an increase in thermal coefficient by 2 to 5%. As a result of the installation operation analysis of at boiling temperature in the evaporator by -10 to +20 degrees, it's clear that with superheating of steam after the regenerative heat exchanger, 140 degrees, the thermal coefficient is increased by 4 to 8%, while the total increase in the heat coefficient is 10–15%. The next slide, please. The next slide, you can see conclusions. So thank you for attention.
For your presentation. It's really interesting. Does anybody have question? I think there are no questions. Thank you very much.
Thank you very much.
The final presentation within our session titled Obtaining of the Novel Organomineral Fertilizers in Pen Granulators, the Technological Fundamentals, will be presented by authors Artem Artyukhov, Sergei Vakal, Victoria Shkola, Victoria Vakal, and Anna Yanovska from Sumy State University, Ukraine. Is Anna Yanovska.
Okay, thank you very much.
Welcome.
it's a very great honor for me to present for you such presentation, result of our research about obtaining of the novel organic mineral fertilizers in fine granulators. And let me start. So, why fertilizers are very important? Because they increase productivity of agricultural soils. And they play one of the main roles in the intensive cultivation of agricultural products and maintaining fertility, ensuring preservation of the stability of structure of land fund. So, as follows from classical use of plant nutrition, phosphorus, nitrogen, potassium, sulfur, and calcium fertilizers has a great influence on soil productivity. And the effectiveness of mineral fertilizers also depends on their proper use in combination with organic, chemical techniques, as well as grow regulators in the cultivation of plant varieties with high yields. To produce fertilizers with high efficiency, which can provide optimal plant nutrition through growing session, new fertilizers should be created. They should contain two parts and a lot of mineral elements, and they should dissolve partially, so in time. A long release of this fertilizer should be consequently, such fertilizers can reduce the negative impact on the environment due to the slow dissolution, and previously developed encapsulated fertilizers don't always satisfy the demands of the agricultural sector of the economy on the efficiency of their application and the cost of production. So proposed a new type of organomineral fertilizers encapsulated allows to increase agricultural efficiency and reduce the agrogenic load on the environment. One of the common methods of encapsulating of nitrogen fertilizers is the deposition of thin polymeric or thick sulfur or phosphate-containing coatings at the rolling granulator on the surface of granular of nitrogen fertilizers. Such fertilizers contain a core of nitrogen, phosphorus, potassium, nutrients coated with inorganic substances containing aqueous solution of potassium, of nitrogen, containing fertilizers in the shell of plasticizer. The use of aqueous solution is well-soluble nitrogen like carbamide, which we used for granulous production, and potassium fertilizers as a binder allows to creation of porous shell structures for entire period of dissolution and granular core, but doesn't slow down the dissolution rate of the elements. Please, slide 3 should be. I forget about slides. Sorry. Okay. Creation of some techniques should include elemental engineering calculation technique of pan-granulator and computer simulation, which should include application to hydromechanical heat exchange, mass transfer, and reaction processes which necessary for the development and granulation equipment, engineering methods of calculation. Therefore, this work presents the developed constructive calculation method of the pan-granulator based on authors' experimental studies. The task, please open slide 5, please. So, task which solved in this research was follows. Phosphate containing shell based on phosphate glauconate concentrate and plasticizers was applied to carbamide granular core, and calcium humate was used with addition of microelements in the forms of chelate compound to the granulum, which was used as a plasticizer. The shell formation process by agglomeration was released in a disc granulator, which you can see on this picture scheme of this granulator. The carbamide granules with size of 2-3 nanometer were fed onto a disc, followed by moisturizing them with plasticizer solution in amount of 10–14% to the mass of phosphate glauconate concentrate with simulation supply of powered phosphate glauconate concentrate with a particle size of not more than 200 microns. The ratio of granular core mass and the coating mass was 1 to 1.1, and drying of the formed granules was carried out at temperatures 64–66 degrees. The use of calcium humate and microelements in chelated form for production of encapsulated fertilizer in proposed technical solution made it possible to obtain fertilizers that contains nitrogen, phosphorus, and potassium, which has granular stretch at least 1.7 megapascals, and commercial fraction yield up to 90%. It makes it possible to increase digestibility coefficient of nitrogen, phosphorus, and potassium components in fertilizers, significantly reduce the negative impact of fertilizers on the environment, and improve quality of plant products. The chemical analysis of the obtained complex organomineral fertilizers was following. Nitrogen, it is nearly 23%, phosphorus oxide nearly 7%, and potassium oxide was 0.3%. Static strength was 2.1 megapascals. So if you look at this picture, you can see that here you have calimag and humate, which is mixed together in some tank. Phosphorate concentrate and avatar was also mixed and go to another tank. Then here you see nozzles and urea or carbamide, which is the core of the granular, and when it is falling in this granulator, it can be coated by all these components together, and we have complex shell for this granular. And on the tray of granulated product, we get product. So how it looks like? Next slide, please, number 6. So this is general view of our carbamide granules, and scanning electron microscopy image of shell, interface, and core of such granular. The shell has homogeneous structure, you can see, without mechanical damage, and uniform distribution of the shell is observed on the surface of the core. Shell is securely attached to the granular core, and obtaining complex of nitrogen phosphorus fertilizer by semi-drying technology by the precipitation of phosphorate powder onto nitrogen-containing fertilizer core, comparing with traditional acidic methods of obtaining nitrogen phosphorus fertilizers, allows to decrease fertilizer suspension humidity from 40 to 50% up to 10–12%. So it decreases the use of coolant for drying product at 70% and gas release for 3 times. Additional economic effect of the use of such kind of fertilizers is obtained due to decrease of fertilizer dissolution in the soil. Next slide, please. So we created pan-granulator software where in general design algorithm for granulation unit for capsulation can be presented on this figure, and novelty of proposed method for calculating the pan-granulator lies in the fact that for the first time design characteristics of the granulator disk and technological parameters of operation were obtained, and analysis of previous works in this industry shows that until now calculation error using existing methods has been significant. Next slide, please. Here you can see calculating procedure, how a program was calculated, some technical moments of this granulating technology. I'm not very strong in this part of our investigation. I'm sorry. And next slide, following calculation, you can see. And next slide. So this program produced pan-granulator design and some technical characteristics. And next slide, we came to the conclusion that analysis of IP documents and literature date made possible to highlight the shortcomings of existing organomineral fertilizers and propose new composition of encapsulated fertilizers with a high content of micro and micro elements. So description of new method of organic mineral fertilizers obtaining was given, and advantages was also shown. It is proposed to obtain organic mineral fertilizers for new composition in pan-granulator, taking into account presented advantages of this method. Block scheme of algorithm for calculated of pan-granulator was presented. Date of quality indicators of obtained mineral fertilizers is given. So this work is prepared as a part of research project process and of formation of the novel ecologically safe fertilizers with prolonged action based on phosphorate deposits, raw materials, which financed by state budget of Ukraine. Thank you very much for attention. Your questions, please.
Thank you for your presentation, the recent results of your team. And now we have only one question. The presented procedure is based on the conditions of quasi-static equilibrium. However, during the granulation process, non-stationary processes can occur. In this regard, do you plan to further study the granulator's functionality based on conditions of the dynamic stability? And maybe what criteria of choosing the boundaries in a range between 1.9 and 2.1? What will be presented in further research?
I think that we can we can use this comment and this advance for our future research, but the calculations is not my not such topic at which I can give you a correct answer, because another colleagues was provided such program, and my part is a chemical work and chemical composition and plasticizers and so on. So I will say them about your comment and your recommendations. Thank you very much.
Thank you. Thank you. Yes, we know you have amazing command. You have amazing team, multidisciplinary from different.
It is very multidisciplinary. So
University. Yes. Thank you for your presentation. Thank you.
thank you very much for such possibility.
Overall, dear friends, our session has covered urgent issues of designing equipment for wastewater treatment, studies in wet pollutions, and anaerobic fermentation of wastewater, scientific problems, and recent developments in air conditioning systems and organo-mineral fertilizers have also been presented within our session. And finally, I appreciate all the speakers and the participants contributing to the International Conference on Design Simulation, Manufacturing, the Innovation Exchange. And I wish you that the experience gained at our conference will allow you to be highly successful in your scientific field and make essential contribution to chemical engineering, environmental protection, energy efficient technologies. And I cordially invite you, all of you, to submit extended versions of your papers to the Journal of Engineering Sciences mentioned on the beginning of our session. Thank you for your attention, and together we can do more for science, technology, engineering, and education.
Thank you very much.
Thank you very much
For your contribution to this session and this certificate of appreciation as our acknowledgement. Thank you very much. Thank you very much. Dear participants, I would like to take this minute and let me to sum up some information. During this conference, during these 2 days, one keynote session and 8 technical sessions were held. During them, we have heard 3 keynote presentations from Ukraine, Poland, and Turkey. 45 oral presentations from all cities from Ukraine, from Poland, from other countries. Also, you can find 55 poster presentations on the website of the conference. It will be visible for all of you and all other interested persons. Traditionally, we select the best presentation award and one best poster award. Actually, it's not easy to select this year because all presentations were well presented, and organizing committee will need to gather again and find the best presentation award and best poster award. This information will be visible on the website and social media shortly. The agenda of this 4th edition of conference is fully completed, and I would like to say thank you very much to all participants for your research papers, presentations, and posters. Thank you very much to reviewers for your scientific evaluation. Thank you very much to session chairs for your contribution to this conference, for your professionalism. Thank you very much to organizing committee for your significant contribution. Once again, we confirmed that together we can do more for science, technology, engineering, and education. I am pleased to announce that the next 5th edition of the conference will be held in Sumy in 2022. Traditionally, it will be the 2nd week of June. The website will be updated by the end of June, and the submission system will be opened. The deadline for submission is October 1, 2021. Looking forward to your participation. Thank you very much and see you soon. Thank you very much.